Imagine a world where the skies literally rain diamonds. Not just tiny specks, but colossal gems that would make Earth's wealthiest jealous. Sounds like an unimaginable treasure trove, right? Think again. The fascinating, yet harsh, reality of these cosmic diamond showers reveals why these riches remain forever out of our grasp. Imagine a world where the heavens don't just open with water, but with a glittering cascade of pure diamonds. Sounds like a fantasy, doesn't it? Yet, across the vast cosmic ocean, scientists are increasingly convinced that such phenomena aren't just possible, but probable. We're talking about a whole new category of celestial bodies, the diamond worlds. These aren't your typical rocky planets. Picture super-Earths, planets far more massive than our own, but still primarily rock and metal. Now, imagine if some of these giants formed in regions incredibly rich in carbon, rather than oxygen. Under the crushing embrace of their immense gravity and searing internal temperatures, that carbon transforms. Think about it, immense pressure squeezing carbon atoms together. What do you get? Diamonds. But the spectacle doesn't end there. Some theories extend this to mini-Neptunes, smaller gas giants with dense atmospheres. Deep within their turbulent, hydrogen-rich envelopes, where methane abounds, extreme pressures and temperatures could break apart those methane molecules, creating free carbon that then crystallizes into brilliant gems. Rains of liquid hydrogen and helium are theorized to carry these crystalline treasures down, like cosmic snowfall. But how could such wonders ever be within our grasp? We just touched upon rains of liquid hydrogen and helium carrying these crystalline treasures down, like cosmic snowfall. But what incredible forge creates such wonders, and how could such brilliance ever be within our grasp? Imagine a world where the very air around you isn't just heavy, it's an unimaginable vice. On this exoplanet, the atmospheric pressure isn't just severe, it's millions of times greater than Earth's, crushing everything inward with relentless force. And the heat? It's not merely hot, it's a searing inferno, thousands of degrees Kelvin, enough to vaporize most known materials. It's within this cosmic pressure cooker, this brutal crucible, that the magic happens. We theorize that extreme pressures and temperatures could break apart those methane molecules. Well, they don't just break, they're ripped apart, their hydrogen atoms stripped away, leaving behind a bounty of pure carbon. This free carbon, under such unthinkable duress, has only one destiny: to crystallize. It transforms, atom by atom, into the hardest substance known, pure diamonds. Then, as theorized, the skies literally weep these precious gems, carried down through the atmosphere by rains of liquid hydrogen and helium. A glittering snowfall of pure diamond. But wait, if these diamonds are forming and falling, why isn't humanity already planning intergalactic treasure hunts? What about this cosmic pressure cooker makes these riches forever out of reach? Imagine a world where the very air you breathe is a precursor to untold riches. On this particular exoplanet, the story begins not with a pickaxe, but with pure methane, thick and swirling in the turbulent upper atmosphere. But this isn't Earth. Here, the conditions are utterly brutal. Intense lightning storms, fueled by unimaginable energy, rip through the methane molecules. Each electrifying bolt acts like a microscopic sledgehammer, shattering the strong bonds holding carbon and hydrogen together. Once freed from their gaseous shackles, these solitary carbon atoms are plunged deeper into the planet's crushing embrace. We're talking about pressures so immense, so utterly unfathomable, that they dwarf anything experienced on Earth. It's within this cosmic pressure cooker, deeper than the swirling rains of liquid hydrogen and helium mentioned before, that a miracle of geology unfolds. The unattached carbon atoms, under literally millions of times Earth's atmospheric pressure, are forced into an incredibly tight, tetrahedral lattice. This isn't just carbon, this is pure, crystalline diamond, forming in a glittering snowfall. But how does something so precious become so impossibly out of reach? What incredible forces are at play that make retrieving even a single gem an interstellar pipe dream? Imagine the ultimate cosmic tease, planets where precious, crystalline diamonds rain down, forming in a glittering snowfall, each facet catching the alien sunlight. But how does something so precious become so impossibly out of reach? What incredible forces are at play that make retrieving even a single gem an interstellar pipe dream? The answer whispers across the void, a chilling declaration of scale, distance. These diamond worlds aren't in our cosmic backyard, they are light years away. To comprehend light years is to grasp a chasm so profound it bends the mind. It's not just a measure of space, but of time itself. The distance light, the fastest thing we know, travels in a year. Imagine embarking on such a journey. Even if we could harness propulsion technologies far beyond our wildest current dreams, capable of approaching the speed of light, it would still take centuries, millennia, for a return trip. Our most advanced probes crawl at a glacial pace compared to such cosmic velocities, rendering any thought of commercial mining, or even a sample return, an utter impossibility. The universe, in its infinite majesty, has placed its most dazzling treasures behind a barrier of unfathomable, unyielding space, ensuring they remain forever sparkling just beyond our grasp. Imagine a world where the very air shimmers with unimaginable wealth, a sky that weeps pure, flawless diamonds. Sounds like paradise, doesn't it? But here's the brutal truth, any dreams of collecting even a single shard are instantly, violently extinguished. Descend into this glittering inferno, and you're not just facing a storm, you're plunging into a planetary hellscape. The atmosphere itself is a suffocating shroud, pressures so immense they would flatten steel as if it were tissue paper. Think about it, what kind of material could withstand a squeeze powerful enough to turn gas into solid, crystalline rain? Then there's the heat. Not merely hot, but a superheated forge, thousands of degrees hotter than Earth's molten core, designed to incinerate anything foolish enough to trespass. And what about the composition of this atmosphere? We're talking potentially corrosive elements, whipped into Mach velocities, tearing through any advanced alloy we could conceive, reducing our most resilient probes to scattered atoms in mere seconds. It's an environment where the very notion of survival is an absurdity, where even the sturdiest spacecraft would be ripped apart, crushed, and vaporized long before it reached the diamond layers. The universe, in its infinite majesty, has placed its most dazzling treasures behind a barrier of unfathomable, unyielding space, ensuring they remain forever sparkling just beyond our grasp. Imagine a world where it rains pure diamonds, where skies shimmer with untold wealth falling from the heavens. Breathtaking, isn't it? Our minds immediately leap to mining operations, to fleets of ships returning with glittering payloads. But then, a cold splash of cosmic reality hits. How do you even begin to harvest a fortune that exists under pressures unfathomable, at temperatures that would make our sun feel like a lukewarm bath? Picture the journey, through an atmosphere of superheated gases, winds that could strip mountains bare. Our finest alloys, engineered to withstand the most extreme terrestrial conditions, would instantly vaporize. What material could possibly form a shield, a drill, a container, against a force that would flatten an entire continent? Our most robust robotics. They'd seize up, circuits fused, their sophisticated mechanisms crushed into atomic paste before they'd even touched the outer atmospheric layers. And power? What energy source, what revolutionary battery, could sustain operations in an environment designed by the universe itself to obliterate? Even our sturdiest spacecraft, painstakingly crafted, would be ripped apart, crushed, and vaporized long before it reached those diamond-rich depths. The universe, in its infinite majesty, has placed its most dazzling treasures behind a barrier of unfathomable, unyielding space, ensuring they remain forever sparkling just beyond our grasp. We've established the brutal, crushing, vaporizing impossibility of ever reaching those glittering depths, the universe ensuring its diamond treasures remain forever just beyond our grasp. But what if the real bounty of these impossible worlds isn't the diamonds themselves, but the sheer, mind-bending revelation they offer? A scientific motherlode, far more precious than any gem. Every searing storm of liquid carbon, every impossible atmospheric layer where pressure transforms gas into solid, is a cosmic laboratory operating at scales and conditions we can only dream of replicating. How do planets form with such exotic chemistries, where carbon isn't just a building block but an oceanic constituent? What fundamental forces are at play, allowing entire worlds to crystallize carbon into diamonds, not in tiny specks, but in vast, unimaginable quantities? These exoplanets challenge our most basic assumptions about planetary formation, stretching our understanding of the universe's diversity to its absolute limits. What other impossible wonders await discovery, hiding their profound secrets behind equally unyielding barriers? In unraveling these celestial enigmas, we don't just learn about distant worlds, we glimpse the very blueprints of creation, a scientific treasure infinitely more valuable than any diamond.